Okay, this is number 14 on section 2.2. So here we're working with general solutions of linear equations of higher order. So the problem states, so I've already written the problem, and number 14 says, or 13 through 20, so we're given a third order homogeneous linear equation, and we're given three linearly independent solutions. And the goal is to find a particular solution satisfying, right, these initial conditions. So let's go ahead and start. So the goal is, so this was all the given information. So there's usually, right, a given and a goal. So that's my given, and my goal is to find a particular solution. So goal is to find a particular solution. And we're going to denote our particular solution as y sub p. Okay, so that's what the book calls it. So in order to find this particular solution, y sub p, we need to find the general solution, and we've been doing that a lot in section 2.1. But the nice thing about this problem is the three linearly independent solutions are already given, so you don't have to find them. We already know the specific form that it has. And so I'm looking at theorem, let's say, I believe it was theorem 4 in your book. So by theorem 4, right, which is the general solutions of homogeneous equations, and we are given a homogeneous equation in this case. And it says let y1, y2, all the way to yn. So in this case, I'll make this a little bit smaller. Here's my y1, y2, right? My n is 3, right, because we only have three linearly independent solutions. And they're given, we have a form of our solution. So let's go ahead and write that down. That is going to be my capital Y of x. And on theorem 4, you're given, of course, y to the n. That's our y to the third plus, right, p1 of x. Well, actually, let's go ahead and write it down. It's not a bad idea since we're learning here. So I'm going to go ahead and write, so by theorem 4, okay, we have our three linearly independent solutions. We have our general solution, so we have capital Y of x equals, and then we have C1 Y of x. Okay, so C1, well, we have a y of x, right? It's right here, so maybe let's make that, all right, so these guys. So C1 Y of x, which is e, and I believe I'm missing a e to the x there. That should be e to the x. Just did not write that down correctly. And then we have plus, right, C2, and then my y2 is e2 to the x, and then finally plus C3, and then we have e to the third x, the last linearly independent solution. So e to the 3x. So here's my general solution, right? Let me just change to my pointer here, right? It's a linear combination of these three linearly independent functions. So that's nice because they gave us the linearly independent solution, so we were able to just construct these. So now let's find the particular solutions, which is what the problem is asking for, and that's why they give us these guys, right? We're going to use these initial conditions. Now, the initial conditions, right, we have a function, right, y of 0, we have the derivative, and we have the second derivative. So we are going to be taking the first derivative and the second derivative in order to help us find these coefficients. So let's begin our successive differentiation. So we have, move this up a little bit. Okay, so we have, and we can just call this y. So y prime of x Okay, so we're taking the derivative, right, of the sky. And so y prime of x is going to be, well, this is pretty easy because it's just a nice exponential function. So c1 e to the x, and this guy is going to be 2 c2 e to the 2x plus 3 c3 e to the 3x. Okay, so now let's find the second derivative. So we have y double prime. And similarly, right, we have, again, we're going to take it of this guy right here. So we have, c1e to the x plus, that's going to be 4 c2e to the 2x plus 9 c3e to the 3x. Okay, so I found my first derivative and I found my second derivative. And again, the reason I'm doing all of this is because I want to find these coefficients in order to, again, find our particular solution, or y sub p. So let's use our initial conditions. So we have, well, y of 0, which is nice. Okay, so y of 0, and so I'm going to insert 0 for every x I see. So I have c1 e to the 0 plus c2 e, well, 2 times 0, which is going to be 0, plus c3 e to the 3 times 0. But y of 0 is going to be 0. So I'm just going to go ahead and write that down. And let's go ahead and just simplify this. So we have, this is great. This is just a big 1, right? E to the 0 is a big 1, a big 1. So I really have c1 plus c2 plus c3 is equal to 0. Okay, so I'm just going to go ahead and box that. Okay, so now let's do the same thing with y prime of 0. Well, y prime of 0, right, there's my y prime of x. So y prime of 0 is, again, c1 e to the 0 plus 2c2 e, and then again it's 2 times 0. I'll just go ahead and write 0 because anything times 0 is 0. 3c3 e to the 0. But we were given that, I believe that was 0. Right, y prime of 0 is 0, yep. And so again, right, these guys are 1s, so this implies c1 plus 2c2, right, times 1, plus 3c3 equals 0. And one thing I do want to point out on your homework, and again, this is just, the more math you take, the better mathematical writer you become. So here I have obviously an equation, right? This is an equation, and we know that's equal to 0. I'm not going to write equals here because it's going to be equals this equals 0. It doesn't make sense. I mean, this statement implies this new equation. Okay, so let me go ahead and box this guy, and then finally our second derivative, so y double prime of 0. So that is going to be, again, c1 e to the 0 plus, we love e to the 0, 4 c2 e to the, again, 2 times 0 plus 9 c3 e to the 0. And I believe our initial condition was, so 3. Y prime of 0 equals 3. So again, this implies, right, these guys are just 1s. C1 times 1, C1 plus 4 C2 plus 9 C3 equals 3. Okay, so there is our third equation. So I'm going to put these guys together, and I'm going to form a system of linear equations because we know how to solve those from algebra. Let me move this up a little bit. Okay, so whoops. So we have C1 plus C2 plus C3, C1 plus 2C2 plus 3C3 equals 0, and C1 plus 4C2 plus 9C3 equals 0. So this is a system of linear equations, of 3 linear equations, in 3 variables, right? This should remind you of, I mean, if you wanted to, well, you don't want to use it for this problem, but x plus y plus, z equals 0, x plus 2y plus 3z. You might have seen it in college algebra where where you solve these by either the addition method or you can use matrices. We're going to use matrices because matrices are fun, and I mean these matrices they can be larger than 3x3s. And eventually we use computers for this, and so let's go ahead and use our knowledge of that. And actually I do want to stop here. I'm going to continue in the next video because the problem is about 10 minutes, and again, when I exceed 10 minutes, it gets pretty long to upload. So we're going to solve this system in the next video, because again, we want to find C1, C2, and C3, because once we do, then we're ready to write our particular solution. So I will stop right here.